Hi, my name is Zoe Williams. I am a senior at Athens High School, and this is my project, Bassoon, Dinosaur Innovation. This title comes because the bassoon itself has been around since the 1700s, and its predecessors were seen even throughout the Middle Ages. This is enough time for people to figure out by trial and error where the tone holes should be, and tone holes are what allows the instrument to play a step up or a step down each time on the musical scale. Every instrument has these, and the interesting thing about the bassoon is that it doesn't follow the standard rules around how these should be placed. For instance, last year I was attempting to create my own bassoon just from scratch. I had just a long tube made of wood, and I tried drilling the holes based on what other instruments use, which is 6% of the total length of the instrument, the physical length per semitone or per half step. But this didn't work at all. It ended up being 3 holes very close together, and then a huge gap, and then 3 more holes very close together. It was very strange, and I wanted to figure out why that was, why this weird placement existed. So, last year's project, it was just plywood with holes drilled in it. The main focus of that was finding the ideal bore angle for a bassoon, and I used the equation F equals NV over 4L plus X. So the frequency, the pitch, is equal to the number of the harmonic times the speed of sound over 4 times the length of one part of the instrument plus the other part. There are 2 different cones. So L would be the main part and X would be the smaller part with the vocal, as it's called, on the bassoon. But this project is more about why the tone holes didn't work. And I was thinking, the bassoon that I made, its tone holes were just drilled straight into the side of some plywood. Whereas if you look at the modern bassoon professionally made, it also has a strange tone hole placement, but the difference is on that model that the holes are drilled deeper at an angle and have different diameters. So I figured that must be why this problem was happening. So I decided to test out different sizes and lengths of tone holes on a constructed model to see if that actually was what was going on, why I was seeing these strange results. So to test this, basically I had one long tube. I am using PVC tubes here whereas normal bassoons are conical, but this is for ease of access, and there is no difference in how the tone holes should place. Hypothetically, if I applied anything I learned here to the conical instrument, it should be the same. So I had a one long tube with a PVC T connector, and I tried inserting different diameters and different lengths of tube, and I was comparing it to all the rest of the data and all the other trials to see which one had the greatest effect on the pitch and if that could account for what I saw. So I tried 4 different series, as I call them, of diameters, basically. I tried varying the ratio of the diameter of the bass instrument, just the tube, and the tone hole that I tried making. So I had just a 1-to-1 ratio, just the same size hole. I also had a 1/5 ratio, also an 8-to-25 ratio, and a 3-to-5 ratio. So I tried, and when you play this instrument, you can switch which side of the tube the mouthpiece is on, and this way I could simulate different placements of the tone hole, closer to the mouthpiece at 25 centimeters and further away at 104 centimeters. And ultimately I was getting changes in hertz of This is with a 1-to-1 ratio of 31.25 hertz. Also 6 hertz with a 1/5, 9.75 with an 8 to 25, and 8 hertz at 0.6. So all of these differences weren't nearly enough to compensate for the strange effects that I found previously. And this level, it's just not enough to warrant such strange tone hole placement. It is a bit of a change, definitely, but it's only by a few semitones. Definitely not enough to see what is going on. There's definitely something else influencing the bassoon here, and I would really love to figure out what that is through more research after quarantine. And yeah, any suggestions would be greatly appreciated. Here is a picture of some of the different series that I tried, the 4 different ones, so you can see how different all of these were. And definitely the 1-to-1 ratio had the biggest difference, but I can't imagine having a tone hole greater than the diameter of the instrument itself. That would be like a funnel. That isn't seen anywhere on any instrument, as far as I know. But yeah, 1-to-1 ratio and as close as it can be to 1-to-1, it definitely shows the most change, as you can see by these graphs. This one had the largest slope. This one actually went down. The blue is 104 centimeters from the mouthpiece, and orange is 25. And in all of them, the orange had more of an effect when it was closer to the mouthpiece, and the 1-to-1 ratio also had the most effect out of any of them, but definitely not enough to warrant what I saw. So yeah, I hope you enjoyed, and best wishes.